Hello and welcome to Elimu Live. My name is Arthur Kithinji from ACK St. Michael Model Schools, Ongata Rongai. Today I'll be taking you through grade 7 mathematics. The strand is measurement and the substrand is Pythagorean theorem or Pythagorean relationship. So we are looking at Pythagorean relationship. Now, when we talk about Pythagorean relationship, this is a relationship between the sides of a right-angled triangle. And it was discovered, or it was named after a Greek philosopher called Pythagoras. It was named after Pythagoras, who was a Greek philosopher and a mathematician. When we talk about the sides of a right-angled triangle, learners remember that the word tri means three. So a triangle is any three-sided figure. And when we talk about a right-angled triangle, this is a triangle which has got a right angle at the base. So this is the right angle, and this is what we call a right-angled triangle. And the relationship I'm talking about is about the two shorter sides and the longer side of a right-angled triangle. And this is what we call the sides. The side directly opposite to the right angle is called the hypotenuse. This is called the hypotenuse. Whereas the other two shorter sides are called legs. This is one leg, and this is another leg. So the two shorter sides are called the legs, and the longer side is called the hypotenuse. So we are going to explore more about how these three sides of a right-angled triangle are related, or what Pythagoras discovered when he did his mathematical research about the right-angled triangle. Now, the Pythagorean relationship states, this is what the Pythagorean relationship states. It states that the sum of the square, of the shorter sides, which we are calling the legs, is equal to the square of the longer side, which we are calling the hypotenuse. So the sum of the square of the shorter sides is equal to the square of the longer side, which we also call the hypotenuse. So the sum of the square of the legs is equal to the hypotenuse. Now, coming back, let's call one of if one of the legs is A and the other one B, which is irrespective of the changes because they are related by addition. So this can be A, and this can be B, and this can be B, and this can be A. This other side of the hypotenuse is C. So we call them A, B, C. So using that, we have what we call an equation relationship. We say that A squared plus B squared is equals to C squared, which is a summary of the Pythagorean theorem or the Pythagorean relationship. As you can see on your screen, the relationship is that the sum of the square of the shorter sides, which is A squared plus B squared, is equal to the square of the longer side, which is c squared. Any side, mark you as I've said, any side can be either a or b, provided it's the shorter side. So let's try to use the Pythagorean relationship, or let's try to use the Pythagorean relationship to understand more on what we are saying and to get the side of the missing side. Let's use the Pythagorean relationship to get a missing side. So if you are given a right-angled triangle, you are told that this side is 4, this side is 3, then you are asked to find the missing side, which is the hypotenuse, using the Pythagorean relationship or theorem. So according to our equation here, or our equation relationship, is that a squared plus b squared is equals to c squared. So we said, let this be c, let this be b or a, and this be a. Any of them can be either a or b. They are all shorter sides, or the legs. They can take any letter. So if this is a and this is b, then 4 squared plus 3 squared is equals to c squared, whereby we are supposed to get c to know the measurement of this side and not c squared. So the square of 4 is 16, the square of 3 is 9, and still let's maintain c squared. 16 plus 9 is 25, so c squared is equals to 25. What we want is c minus the exponent 2, or what we call the power. So for us to remove the power or the exponent, we have to take the square root of c. And what you do to one side of the equation, you must also do to the other side of the equation. So let's take the square root of 25 as well. The square root of 25 is 5, and the square root of c squared is c. So we eradicate the exponent 2 by getting the square root. So therefore, c is 5 centimeters, if these were all centimeters. So this is 5 centimeters. Let's have a visual explanation. Let's have a visual explanation of what we have just seen, or what we have just agreed upon, that the side is 5 centimeters. We all know what is a square. So let's come and have a drawing of our square. Oh, sorry, of our right-angled triangle. We have said this side is 4, this side is 3, and we have seen this side is 5. So let's make a 4 by 4 square, because 4 squared means 4 by 4. So let's come up with a diagram of a square which is 4 by 4. So we expect to get something that looks like this. That means it's 4 by 4 squared. And then on this side, we'll have a 3 by 3 square. A 3 by 3 square. 3 by 3 square. We expect to have something that is close or similar to this. This is a 3 by 3 square. And then let's have a 5 by 5 square. I hope it fits well. You can all see learners. This is a 5 by 5 one. 2, 3, 4, and 5. And then here we have 1, 2, 3, 4, and 5. This is a 1, 2, 3, 4, 5 by a 1, 2, 3, 4, 5 squares. So now let's count the sum of the squares. Let's count the sum of the squares. Let's start with our A. This is our A, this is our B, and this is our C. So for our A, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, which means it's the square of 4. So the total number of squares here are 16. Here we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So the square of 3 is 9. And then here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. And the square of 5 is 25. Now, we have said that A squared plus b squared should be equal to c squares. Let's count the total number of squares in A and B. This is 16. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, and 25. Therefore, A squared plus B squared is equals to 25. When we add 16 plus 9, we get 25, which is the square of 5. And that is the relationship that we are calling the Pythagorean relationship between the two sides, the three sides, sorry, of a right-angled triangle. Remember, students, this does not apply to other types of triangles. We have other triangles like the scalene. We have other triangles like what we call equilateral triangles. We have the equilateral triangle. We also have what we call the isosceles. This does not apply in these. It only applies on a right-angled triangle. It only applies on a right-angled triangle. That is now, this is the visual explanation of the Pythagorean relationship and the equation that holds. Therefore, we now want to go and look at, let's look at an exercise. Let's look at our exercise and see what we have. For question 1 on the screen, we are asked, which of the following are right-angled triangles? I'll do A, which is 3 centimeters by 6 centimeters by 20 centimeters. So A is 3 centimeters by 6 centimeters by 20 centimeters. Good. Therefore, if we use our relationship that we have here, let's fix our right-angled triangle correct. So this is our right-angled triangle that we have. The shorter sides are 3 centimeters and 6 centimeters. We said that they can take any. So this can be 6, or this can be 3 centimeters, and this can be 6 centimeters. This can be our A, this can be our B. We said the legs don't matter. Any can be either side. And our C is 20 centimeters. Let's see if the equation holds. We said the equation states that A squared plus B squared is equals to C squared. Our A, let's put our numbers right. Our A is 6, so 6 squared. Our B is 3, so 3 squared. Our C is 20, so 20 squared. 6 squared is 36. 3 squared is 9. And the square of any 2-digit number can be gotten easily. I want to teach you how to get the square of any 2-digit number just here. What you need to do is to know the squares of the numbers between, which I write here and I will not rub until the end of the lesson, between 1 and 9. So learners, the squares of the first 9 numbers are, the square of 1 is 1, which means is 1 times 1, which is 1. The square of 2 is 2 times 2, which is 4. The square of 3 is 3 times 3, which is 9. The square of 4 is 4 times 4, which is 16. The square of 5 is 5 times 5, which is 25. The square of 6 is 6 times 6, which is 36. The square of 7 is 7 times 7, 49. And the square of 8 is 8 times 8, 64. The square of 9 is 9 times 9, 81. So I'll maintain these until the end of the lesson for our reference. Now we want to see how we get the square of a 2-digit number. I said I'll teach you a shorter method of getting the square. So we want to get the square of 20. So just come and write 20 squared, then write your equal sign, then have 3 dashes that you shall fill. The first gap we shall fill with the square of the first digit. which is 2, or the digit in the tens. So 2 squared is 4. And then the last box, let's leave the middle one. We shall fill with the square of the digit in tens, or in ones, sorry, the first digit in ones, which is 0. So 0 squared is 0. And the middle term we shall fill by the square, the middle term we shall fill by multiplying the numbers that we have. 2 times 0 times 2. 2 times 0 is 0. 0 times 2 is still 0. So the square of 20 is 400. We shall get to explore more of these examples as we continue doing these squares of the sides, which means this is 400. 36 plus 9, 36 plus 9 is 45, which means that 45 is not equal to 400. Therefore, this is not a right-angled triangle. So A does not have the qualities we know or we have seen from the Pythagorean relationship. Let's look at our exercise again and pick another example. So let's pick B, which is 5 by 9 by 12. So B is 5 centimeters by 9 centimeters by 12 centimeters. Then we shall come and draw the same sketch. That our right-angled triangle. Let this be our A, this be our B, and this be our C. So we have 5 centimeters by 9 by 12. Therefore, A squared plus B squared is equals to C squared. A is 5, so 5 squared plus 9 squared is equals to 12 squared. 5 squared is 25. 9 squared, from these, we have seen 9 squared is 81. And then, what is 12 squared? 12 squared, according to our method, we said, you get the square of the first digit and put the answer in the first dash. So 1 squared is 1. Get the square, jump the middle term, get the square of the last digit, which is the digit in ones, 2 squared, which is 4. Then multiply 1 times 2 times 2, the exponent. So 1 times 2 is 2, 2 times 2 is 4. Therefore, the square of 12 is 144. And this is 144. We know that 81 plus 25 gives us 106. Therefore, also, learners, we are very unlucky that also this does not qualify to make a right-angled triangle. So we cancel that and we move to another example. Let's move to another example on the screen and check. We have C, 12 by 16 by 20. So C is 12 centimeters by 16 centimeters by 20 centimeters. So we have a right-angled triangle that measures 12 by 16 by 20, which means our A is 12, so 12 squared plus 16 squared is equals to 20 squared. Let's check again. We said 12 squared, we have seen it here, is 144. Let's check 16 squared from our simple experiment or how to get squares. Square the first digit, which is 1. 1 squared is 1. Jump the middle term, square 6, which is 36 from our list here. And then 1 times 6 is 6. 6 times 2 is 12. What we are going to do in this case, look carefully, we are going to pick the number in ones and carry any other number to the next group of numbers. So we shall write 6, we carry 3 and add it to 12. So 12 plus 3 is 15. We shall write 5, carry the 1 to 1, and 1 plus 1 is 2. Therefore, 16 squared is 256. 20 squared, we saw that is 400 previously, a few minutes ago. Therefore, we shall add 144 plus 256. This is 0. This is 9 plus 1 that we carried is 10. 2 plus 1 is 3 plus 1 is 4. Therefore, 400 is equals to 400. What does this mean? This means that our equation holds, that a squared plus b squared is equals to c squared, such that our a was 12 squared, our b was 16 squared is equals to 400. So this is a good example of a right-angled triangle. So learners, D is yours. D is yours on the screen. Test if D is divisible by, D is divisible by, okay, D is a right-angled triangle, sorry. So you can check again. I'm sure you have seen on the screen previously. I want us to apply the Pythagorean relationship to get missing sides of a right-angled triangle. Let's apply the Pythagorean relationship to get missing sides of a right-angled triangle. I have the following. A is 9 centimeters. B is 12 centimeters, or can either be, and this is missing. So this is our A. Our B will be so we have a right angled triangle here where A is 10 centimeters, the hypotenuse is 26 centimeters, and what is missing is B or A. One of the legs is missing. And then the last one, which is our C. In our C, we have 15 by 8. So this is a right-angled triangle at this juncture. And then we have K, 15 and 8. Don't be worried about this. The drawing does not mean that there's any problem. What you need to check is where the right angle is. Whatever is directly opposite to the right angle is the hypotenuse, and these are A and B, or the shorter sides, or what we have called the legs. So let's check for A. So let's get the missing side. We know that from our equation, A squared plus B squared is equals to C squared. A squared plus B squared is equals to C squared. And therefore, if this was our A, and this was our B, and this is our C, 9 squared plus 12 squared is equals to C squared. 9 squared we saw previously, or we can even get it here. 9 squared is 81. 12 squared we saw that it's 144, which is equals to C squared. And then 144 plus 81 gives us 225. Therefore, C squared is 225. For us to be able to eliminate the exponent 2 from C squared, learners, we shall take the square root of C squared and also do the same on the other side of the equation, which means if we take the square root of C squared, we shall get C. Let's use prime factorization for grade 7 to be able to get the square root of 225. So we shall use the prime numbers, and the first 4 prime numbers are always 2, 3, 5, 5 and 7. So we shall check for divisibility by these. If this number is divisible by 2, the last digit should be either 0 or 2, or a product or a prime or an even number, which means 225 is not divisible by 2. So let's check divisibility test of 3. It says that when you add the digits, the number should be forming a number which is divisible by 3. 2 plus 2 is 4, 4 plus 5 is 9, and 9 is divisible by 3, which means the entire number is divisible by 3. 7 times 3 is 21, which means we are left with a deficit of 1 here, and then we add this 5, therefore means it's 75. So 225 divided by 3 is 75. Still again, check for divisibility test of 3. 7 plus 5 is 12, and 12 forms a number divisible by 3, which means the entire number here is also divisible by 3. So divide by 3, we shall get 2 because of 6, remainder 15, and then 15, 5. That means the next number, this is not divisible by 3 because 2 plus 5 is 7, and 7 is not divisible by 3. So let's pick 5. This number is divisible by 5 because it ends with a number divisible by 5. When you divide 25 by 5, you get 5. So for square root, we just pick, if we have 3, this means that we have 3 times 3 times 5 times 5. That is, we have expressed 225 as a product of its prime numbers. So for square root, we shall only pick a pair in this, we shall pick one in this pair of 3s and pick one in this pair of 5s, which means the square root is 3 times 5, which is 15. Therefore, C is 15. C is 15 centimeters. That's how we find the hypotenuse, which is missing. Now, let's do the same. Let's do this example here. It's a bit different, so I want you to follow. That is B. B is means that our A is 10 squared plus our B squared, which is missing, is equals to 26 squared. 26 squared. 10 squared is 100 plus B squared. We shall use our method to get the square of 26. We shall square 2 to get 4. 6 squared is 36. 2 times 6 is 12. 12 times 2 is 24. Therefore, we shall pick 6 and carry 3 and add it here. 24 plus 3 is 27. Then we shall carry 2 and add it here. 4 plus 2 is 6. Therefore, 26 squared is 676. Then we shall be able to take 100 to the other side so that we are left with B squared, put like terms together. So when it comes to this side, we subtract 100. When we subtract 100, we get 576. The square of 576 is 25. So taking square root of both sides, B squared is B, and 576 squared is 25 centimeters. You can check for these using the prime factorization method that we just did. And therefore, our side here is 25. Our side is 25. Our side here is 25 centimeters. And that means we can be able to get either of the shorter sides by ensuring that we arrange our equation properly, carry one, what you are missing to the other, what you have on this side, and be left with what you are missing on the other side. The same case will apply here. We have our shorter side here is 8 squared plus the other shorter side, which is 15 squared. We don't have C squared. So 8 squared is 64. 15 squared is 225. So 64 plus 225 gives us 289. So this is C squared is equals to 289. And then we take the square root of both sides to get away, to do away with the exponent 2. That gives us C is equals to, that should be 17, if I'm not wrong. C is 17 centimeters. Check using the prime factorization or the factor tree that we have done. So those are some of the examples of how you can be able to get a missing side using the Pythagorean relationship of a right angle triangle. Let me go to application. So how do we use the Pythagorean relationship? You have seen painters or builders in the big houses, building houses, they use the ladder. So they have to use the Pythagorean relationship to be able to know the distance away from the wall that the ladder needs to be for it to be able to be very stable to paint on the highest point of the house. Also, when making the stairs, the staircase, it would be very hard for us to climb vertically up, so it becomes a bit easier if you use the Pythagorean relationship. Then I'll go back to our exercise and check. I would like for us to be able to write the questions. We have question 2 and question 3. I'll do one, and then you'll be left to do the other one. Let me do question 2. Question 2, a builder constructed a ramp to take materials to the top of a building 3 meters high. The distance between the foot of the ramp, and the building, the ramp and the foot, the distance between, a builder constructed a ramp to take materials to the top of a building, which is 3 meters high. The distance between the foot of the ramp and the foot of the wall, the foot of the ramp and the foot of the wall is 4 meters. What is the height of the ladder? What is the height of the ladder? So in a diagram of when we visualize the equation, this is the building, which is 3 meters high. This is the distance, the ground distance between the ladder, and this is the ladder, or the ramp. This is the ramp. So the ramp is inclined to the wall, and the distance between it and the house is 4 meters. So we are asked, what is the height of the ramp? That means we shall just use the Pythagorean relationship. A squared plus b squared is equals to c squared. We have our a as 3 squared, our b as 4 squared, and what we are looking for is our c. So 3 squared is 9, 4 squared is 16, and our c squared remains. 9 plus 16 is 25, so c squared is 25. For us to remove the exponent or the power, we must take the square root of c squared, and we must also do the same to 25, what we have done to the side of the other side of the equation, which means our c is 5. Therefore, the distance here is 5 meters, or the distance or the length of the ramp is 5 meters. Thank you very much for the lesson. I know there are so many other examples you'll find in class, but that is just a small summary of what the Pythagorean relationship is all about. I want to thank you for all my viewers in YouTube, Facebook, and also the viewers of KU TV and Elimu Live. I also want to thank ACK St. Michael viewers, my learners in grade 7, grade 8, our parents back at home. It's a long weekend. I wish you a good one. Those who are watching also have a nice weekend.